Hello learners, in this lecture we are going to learn about correlation analysis. First, consider the situations here. Is there any relation between shoe size and height? Is there any relation between number of hours you exercise every day and your heart rate? Is there any relation between math scores and overall scores in exam? Is there any relation between temperature and earthquake? Is there any relationship between temperature in summer and water consumption? Here you can see we are interested about the relationship between these variables. There are many situations where the objective of the study is to see the relationship between the variables. Correlation analysis is one of the most widely used statistical measures for studying the relationship between the variables. Correlation analysis was first developed by Sir Francis Galton and then reformulated by Karl Pearson. Correlation analysis enables us to measure or quantify the relationship between the variables. The statistical problem in correlation analysis is to find out if there is a correspondence of variation between two or more variables. Correlation analysis is concerned with two or more sets of data, not only with one set. When we measure interrelationship between two variables, then it is called simple correlation, and relationship among more than two variables is termed as multiple correlation. What is correlation? The correlation is the measure of the extent and direction of the relationship between two variables in a bivariate distribution. Correlation analysis involves various methods and techniques used for studying and measuring the extent of the relationship between two variables. It also helps us to decide the strength of the linear relationship or association between two variables. Now, what are the advantages of correlation analysis? Correlation analysis measures the strength of relationship between the variables. It also provides the direction of the relationship between the variables. Correlation analysis reduces the range of uncertainty in matter of prediction. Prediction is not perfectly accurate here but helpful. Although correlation is a powerful tool, there are some limitations in using it. Correlation only describes a relationship, it does not tell us why. That means correlation does not imply causation. Correlation is affected greatly by the range of the dataset. If there is outlier in the dataset, it significantly alters the correlation. It can result in apparent statistical evidence that a relationship exists when in fact there is no relation. Correlation does not capture strong nonlinear relationship between variables. There are two types of correlation, positive correlation and negative correlation. Let us consider two variables x and y. If both the variables are varying or changing in the same direction, that means if one variable is increasing, the other is also increasing, or if one variable is decreasing, the other is also decreasing, then the correlation among the variables is termed as positive correlation. Here you can see, in case of positive correlation, as x is increasing, y is also increasing. As x is decreasing, y is also decreasing. So here variables are changing in the same direction. Besides, if the variables are varying in the opposite direction, that is, if one variable is increasing, the other one is decreasing and vice versa, then the correlation between the variables is termed as negative correlation. Here you can see, as x is increasing, y is decreasing, or as x is decreasing, y is increasing. This is the situation for negative correlation. Here are several examples of positive and negative correlation. The relation between Income and expenditure on luxury goods exhibits positive correlation. The relationship between a student's study hour and his test score also exhibits positive correlation. On the other hand, the relation between price and demand of a commodity exhibits negative correlation. The relationship between students' absence in class and their grades also exhibits negative correlation. There are two types of methods for studying correlation. One is graphical method and the another one is algebraic method. There are many graphical methods of determining correlation, but amongst all graphical methods, scatter diagram is the most widely used graphical method of determining correlation. On the other hand, Pearson's correlation coefficient and Spearman rank correlation are the most common algebraic methods for determining correlation. We are going to learn these three methods of determining correlation.